Good morning. I was just telling Raymond this morning that it's such a great time to be in this business. Such a great pleasure to be here, an honor to be here, especially today, especially with this release, especially with the stuff that we're going to show you today. And I'm super excited. You know, I'm an Active Directory kind of guy. Raymond is a
Windows expert, IT pro, is it, as Microsoft calls it.
Yeah, MVP. MVP. So today we're going to talk about Active Directory, about running Active Directory domain controllers on Hyper-V and Azure. And we're going to show you why that is important and why you want to run that securely, safely, and on your own terms. Raymond is, as you said already, a Windows IT Pro expert MVP.
Yes.
Want to add something to that?
No, I've been independent since 16 years, and we're from the Netherlands, both.
Yeah, we're both from the Netherlands, so we try and speak as fluent English as we can, but I bet it'll show. And while Raymond has been independent for the last 16 years, I've been employed by a company in the Netherlands for the last 15 years, so we're both kind of stable and are building on that platform on discovering the newest of stuff. So what we're going to show you today is tools that have been around since Windows NT 3. And what we're going to show you is stuff that is in Windows 10, undocumented, unannounced stuff. So sit tight. We're going to talk about the current situation. We're going to talk about challenges when you do virtualize domain controllers, when you virtualize them on Hyper-V, or if you're really on the edge, virtualizing them on Azure, which is cool, kinda. Not to us, it's cool. Going to talk about those challenges and how you can solve them. So the solutions that you have in your toolboxes that you can do to make those domain controllers running more safely, more securely.
So, let's ask a question first. Who virtualized their domain controllers? That's cool. And is that virtualized in-house? Who's in the cloud with their domain controllers? One. Brave guy. Good to see that people are actually virtualizing their domain controllers. Well, there's a reason why we're virtualizing domain controllers. Because we want to be flexible. We don't want to be constrained by hardware issues or maintenance with upgrades and stuff like that. So we want to be flexible with them. We want to move them from one piece of hardware to the other piece of hardware. And well, there are lots of reasons why you want to have your domain controllers virtualized. But you have to make sure that it's still safe. And that's what the discussions go around. I've been working with a bank lately. And this bank doesn't virtualize their domain controllers, and there's one reason for it. They require all their domain controllers to be encrypted. And that's the one single thing that you cannot do with your domain controllers when you virtualize them. So that's one bank. The other bank where I've been working like 2 years ago, they did virtualize all their domain controllers. So there's different banks with different IDs, and there is no right to ID, but it's something to think about when you're virtualizing your domain controllers.
So I feel, and I've been working with Active Directory for the last, I guess, 15 years, and I've been looking at it for the first time when Windows 2000 came out, because it was in NT4. I feel that every domain controller is sensitive to an organization. You would say, yes, of course, there's secrets, there's accounts, there's all that stuff. Yeah, but what does that actually mean to an organization? What does it mean that all their user accounts are on the curb when an Active Directory domain controller is being compromised? It means that they may not adhere to the legal stuff that they're required to do. If you work for a company like that, and your user account, your email address, all that stuff is left open, is there available for everyone to use, then that would probably be a breach of contract with you. It may not be legally, but you sure will feel like that. And there's the other stuff. So there's Active Directory integrated DNS. And it's great because you can have DNS and replicate that stuff all over the place, but you can also have it in Active Directory. Have Active Directory replicate DNS. But now, if I have a domain controller and it's compromised, I can see in the DNS cache from what IP address, what websites have been visited. Do we really want that information out in the open? I certainly would not. So, if you look at challenges and you look at virtualizing domain controllers on Hyper-V, we'll first look at Hyper-V and then look at Azure. If you look at domain controllers on Hyper-V, then what you'll see is that there's challenges in terms of performance. Does a virtual domain controller really perform as well as a physical domain controller? Can we make it? Is 97%, because that's roughly what it is 97% enough for my domain controllers? Snapshotting.
Can you guarantee 97%?
Yep, there's the noisy neighbor problem. Exactly. Then there's snapshots. Well, no, I can't even count them on both of my hands. I've been telling all my customers that there's one favorite tool to wreck Active Directory, and that's Hyper-V. It is so super easy. If you're running Windows Server 2008 or Windows Server 2008 or 2 domain controllers, to just corrupt them with Hyper-V. It is super easy. Then, of course, there's security, and that is the main premise of this presentations. Can we guarantee the security of a domain controller running on Hyper-V? Do we trust the Hyper-V administrator? Can we trust the Hyper-V administrator? Any Hyper-V administrators in the room? Can I trust you? I think I can trust you. But I'm not sure. Because there's all kinds of attack vectors that you have on domain controllers. For instance, the integration components. The integration components are part of Hyper-V. The integration components are needed for the VM to be enlightened, to know that it is virtualized, that it is being able to use all those synthesized and enlightened drivers and hardware and stuff. But the integration components, wait for it, run as system. Your Hyper-V admin has system rights on every VM. Did you know that? Then there's, and I can safely ask this question. Anyone from Microsoft working in the Azure team in the room? No. Can I trust you? No one here. Anyone here from Ireland? Just asking. No, it's that kind of stuff. So yeah, Azure is kind of complex. Azure has all that fancy stuff like blobs and networks and services and stuff like that. And you have to know that stuff to be able to safely, securely implement any virtual machine in Azure IaaS. Once you have that, then you need to know the Azure topology. Where is my virtual machine running? Is it still in Europe? Is it still in Dublin? Or is it in Amsterdam? You wouldn't know if it's in Dublin or in Amsterdam. Or if it's the new data center that they're building in Southeast Europe, near your place, where it is currently running. Because they can have it running anywhere. You wouldn't know. It's a region. We don't know. And it affects the way we need to think about virtual machines. Would you mind if your virtual machine in Azure IaaS would be running in Russia? I would. So why is this important? And to me, this is the most favorite part. This is the favorite part of the session, because why is this important? This is about job security for you. This is about getting those legal stuff out of the way for your organization. This is about covering your behind There's attacks going on. We've seen the target attack. We've seen all that stuff. You may not be safe. Further, Microsoft is releasing a product with the next version of Windows Server. It's called Microsoft Identity Manager, MIM. MIM's sole purpose of existence is that Microsoft is saying no Active Directory domain admin can safely say that their Active Directory environment has not been hacked yet. Can you? Can you say you have never, or that your current environment has not been hacked? Can you be sure about that? I don't know. Is it easy?
Yes. Well, there is this one golden rule that I learned, I think, in 2001. If someone owns your hardware, he or she owns the operating system that's running on the hardware. And that's very true for your domain controller. So if you ever had a domain controller running somewhere in a basement or under a desk, somewhere in some obscure place in the world, and you were not in control of who was capable of entering this hardware, you might have someone walking around on this planet who has your keys, the keys to your Active Directory. We may have heard about the hacks that were in the news lately, the pass the hash attacks that actually take your encrypted password from memory and then use it to access something over the network. This is the single and sole reason why you should never, ever use your domain admin credentials on an ordinary workstation in your network. Because every other local administrator on that same system will be able to steal your credentials and then just be you, the domain administrator on your network. That's really simple. So there's pass the hash, there's pass the ticket, which is almost the same. Once we learned that there was NTLM and there was the very unsafe LAN manager, LM. And then we learned Kerberos. Kerberos is much more secure. That's what we all learned from the beginning. I was teaching this. And, and what we learn now is that, well, you can steal the NTLM hash from memory, but you can also steal the Kerberos ticket from memory. And if you steal the Kerberos ticket from this domain controller, from this domain admin in memory, then you're also on the network.
So what you're saying is you have access to the memory space of a virtual domain controller?
Not yet. All these hacks start with the easy target. And what's the easy target in every organization? That's just the ordinary domain member workstation running somewhere in your network. So a hacker will always start with one of these. And if you have a service running as a domain admin on all your member servers, on your member workstations, then you have an issue. If you regularly use your domain admin account for support, you may have an issue. Because every local administrator will be able to steal this password and then use it to access your domain and take over your domain. And that's not all. Last year at Black Hat, someone, well, it's a French guy who wrote Mimikatz.
Anyone know Benjamin? Benjamin Delpy from Mimikatz? Nope?
Okay, well,
oh, you're in for a surprise now.
Mimikatz is a tool that you can download from the internet. It's available with all the source code for everyone. And with Mimikatz, you can do interesting stuff. You can do the pass the hash attack. If you're a local administrator, you can steal credentials from memory and use them. And
I thought
it works pretty nice.
Interesting stuff.
That's really interesting stuff. I have to leave this all work.
Yep.
But that's not all. Because what happens with Mimikatz is that he actually showed us that if someone was ever able to access the secrets on your domain controller, he or she can be anyone on your network. And anyone, I can just say any existing user on your network or non-existing user on your network and take over control over your domain controller. And it's actually by creating your own Kerberos token because you know the secret of the central secret of your Active Directory. So let's go back first how Kerberos works before I show you how that works. Kerberos is based on tickets, and those tickets are handed out by the domain controllers. So if you first log on in your domain, you're logging on and you enter your credentials, and what happens is that on the domain controller there is this secret stored, your encrypted password. So what you do is you send your encrypted password to the domain controller with a request for a ticket granting ticket. This is a long-term key that you can use to access all resources in the domain later on. So you send your encrypted credentials to the domain controller, and the domain controller creates this ticket granting ticket for you. This is encrypted with a secret key that is shared among all domain controllers in your network. And this secret is based in a user account. There is a user in AD that's called KRB-TGT. And this user has a password, and that password is used to encrypt all those ticket granting tickets. So you get a ticket granting ticket, and then when you want to access a resource, for instance, a file share on your network, you go to the domain controller with your ticket granting ticket, and you say, I want to have access to that resource. And as the domain controller knows the secret key of that resource, he sends you back a service ticket. And with that service ticket, you can enter this resource. And the resource knows that it's valid because it's encrypted with its own key.
Now, what you see here is 3 keys in the animation. What if we had that key?
What if you have the KRB-TGT password?
Would that be a problem? What would anyone do with such a thing? Would they create their own service tickets? Please. If you have the password of the KRB-TGT password, you can create TGTs. Now, one thing you should know by now is that TGT validation is, wait for it, client-side only. Because you can have many domain controllers, you don't have to go back to the same domain controller to validate your TGT. So once a TGT is given to you, you have it. Now, if I have the KRB-TGT password for the KRB-TGT account, then I can create my own TGTs. And I can put anything I want in there. Heck, I'm enterprise admin today. And you know what? I'll take domain admin with it. And I'll take the help desk accounts group with it too. You know what? TGTs have a limited lifetime. Yeah, I don't believe that stuff. Just give me a TGT with the enterprise admin group in it for the longest time that a TGT can live, which is 10 years. If someone has the password for the KRB-TGT account, your environment can be owned for as long as a decade.
As long as your password of the KRB-TGT is the same.
Yep, but, and here's the fun thing, and it's 2 slides on, because we're first going to demo this, because it's really super easy with Mimikatz. Microsoft has released documentation on how to change the KRB-TGT password the day before yesterday. Officially, the day before yesterday. Let's demo this stuff first.
So there was no way to actually change the KRB-TGT password.
I have to change.
Yes, and I have to. I lost my connection. Let's see if this will fix itself while I'm connecting. Yes.
This is the hard stuff. Getting the service connected. It really is. Yep.
Am I here? Yes, I'm here. Here I am. I am now connected to the domain controller, being the domain admin. So I was able to steal this domain admin password from someone in the local memory. I will not show that. That's really easy with Mimikatz also. It's all over the internet. And now I am on my system. On this system, there is only one thing I have to know to own this system forever. All I have to know is what is the KRB-TGT secret. So what I'm actually going to do here now is I'm going to steal that secret as soon as I can. So I'll start Mimikatz. Get myself the correct privileges.
Zoom in a bit.
Excuse me?
Zoom in a bit so they can see it, what you're actually typing.
Should I enlarge this a little bit more? I don't think I can. Okay. You're fine?
Yeah.
Okay. And now I'm going to get myself the credentials for the KRB-TGT / Can you turn down the sound of the external input? Before I get something...
Zap.
Okay, now I know that this, before I get the information from all users on this system, what's going on? Am I getting some issues on the internet? I think so.
I think you're not connected.
Did I lose my connection?
This is actually a machine running on Azure, so I think we're having some network difficulties.
Let's see if I can get this back.
Yep.
That's why we shouldn't run it in Azure.
Now this is also the hard part. Mimikatz itself is
Got
easy,
it back,
but
huh?
yep.
/ID. Oops. So user 502. If it's there, if I get, let's say dump /inject, there is another n too much there. User 502 is the KRB-TGT. So what you see here is actually that I have this user here, the KRB-TGT, and this is my secret key. This is the key to the enterprise. If I have this, I can take over the domain just like that. So all I have to do is make sure that I keep it. Let's make sure that I keep it. And bring it onto my own system. So here I am. I am the hacker. And on this system, I am just myself on a local system. That it's not a member of the domain. It's in a work group, and only thing that's happening now is it sits on the same network as my domain controller. So if I have all these secrets here, here's my secret information. I can work with this. And I don't need that much information because I know everything about this domain. Now I know the name of the domain, I know the security ID of the domain, I know the secret password of the KRB-TGT, and actually that's all I need to know to create my own Kerberos ticket. So currently I am nobody, I am not able to access the domain controller. Let's see if I can do that. There. Oh, that's not there. If I don't do typos. You see, I don't have access. There is nothing for me to get there. So currently I'm nobody. Let's be somebody. So I can start Mimikatz to do that. Mimikatz. Let's get myself the right privileges. And now I'm going to create my own key. So what I'm going to do is I'm going to use Kerberos. To create my own golden ticket. And with this ticket, I want to be somebody. So I'm going to be a user. I can just use any username I want to. This doesn't have to be an existing user in the domain. It's going to be on my domain. Next, net.net. Now I have to know the security ID of the domain. Now the security ID of a domain, it is in my secret information that I just caught, but it's not that secret, because the security ID of the domain is the first part of the security ID of every single user in a domain. So if you have user access for any user in a domain, you can just take the large part of the security ID and you know the security ID of the domain. In this case, I have it here. This is the security ID of my domain. And it's added with a number, and that's the relative ID of the user that's logged on. And in the case of the KRB-TGT, it was 502. It's also a known security ID, just like the built-in administrator, which is 100, I think.
500.
500, yes. So this is the security ID of the domain. I have to add an ID for that user, but this one has to exist. This has to be the relative ID of an existing user on the domain. Well, the domain will just start at 1100, I think, for creating users, and then it will increment the number. So if you have a domain with a large number of users, this number can be about any number between 1100 and the number of users that you have on your domain. So, but for now I have a demo domain with a small number of users, so I take a low number. And I need the KRB TGT secret. And that secret is here. It says, this is the NTLM secret. There are other secrets. There are AES encrypted secrets. Those are also usable. But this one is the easiest. So I use the NTLM secret to create my own TGT. Let's see, am I there? I'm almost there. I want to be a member of all those groups that make my life easy on the domain. So let's be a member of, I think, the domain admins and the schema admins.
Oh, that's convenient, yeah.
519, 520.
We're just adding groups here.
Those are the most important groups that you have to be a member of. Around this time, I can do anything on a domain. And let's create my ticket. And the ticket will be a file that I will call hacker.kirby. So, and what Mimikatz actually says, okay, I created this ticket for you, the Kerberos TGT for your hacker account. And all I have to do now is just use it. And using it is just as simple from Mimikatz. I can tell, well, that I want to use Kerberos with a file. And the file is called hacker.kirby. And now it says, well, okay, no problem at all. You're the hacker. So let's exit Mimikatz and see what actually happened. Klist will show me that I currently have a getting ticket for a user called hacker@nextnet.net, which is a user in the domain. So
how long is it valid?
This one is valid until February 10, 2025. That's for the upcoming 10 years.
There you go.
So what can I do now? Can I now access the C drive? Seems something went wrong. The username or password is incorrect. I've seen that before. But I'm not sure why it's... Let's give it a try. maybe this. Yes. So this is the C drive of my domain controller. Access from just a system that is not even a domain member. And what I can do is now is just about everything. I have Active Directory users and computers running here. And it says you're using it on a local system. You cannot do anything with it. Oh no, why not? I just need to connect to a domain. Huh? And my domain name is nextnet.net. Oh, why didn't you just tell me that you were using nextnet.net?
Yeah, why don't you just tell me you're the enterprise admin?
So now I'm here. I can do just about anything. I can start browsing through the domain, be in a domain, create users in a domain. Yes?
Is the hacker account visible in Active Directory users?
No.
So the question was, is the hacker account visible in Active Directory? And the answer is no.
I will show you. And let me create this user.
Will it be viewable in some logs and so on? Will it identify itself in logon entries in security log?
So the question is the creation of the TGT audited?
Yeah.
And the answer is, Raymond?
It is audited, but it is hardly recognizable.
Yep.
There
If you have success auditing enabled on a domain controller, it would just be one of the 3 million success audits per day.
So it's kind of hard to find.
It is kind of hard to find. Yep.
So I have created my user, and to show you, I will just try to find my hacking account that I'm using now. I'm now the user hacker on this domain, and let's see if my domain is actually working fine. It is working fine. Let's find my user ID here. And there is no such user in the domain. So I am a non-existing user, and I can do everything with the domain. And I will be able to keep doing this until the KRB TGT password expires. And it doesn't expire. What Microsoft tells you, actually, there are 2 ways. There were, before this week, there were 2 supported ways to change the KRB TGT password. One was, migrate your domain from Windows 2000 to Windows 2003. That's been a while. And the other way was restore your complete domain from a backup. Whoever did that. So you can be sure that the KRB TGT secret in your domain has been the same, at least from when you upgraded to Windows Server 2003.
2008.
Okay,
2008.
Okay. But at least it's been for years. And if you're not doing anything, it will stay that way for years. And if you ever had that domain controller running somewhere in a basement and you don't know where you left it, then you better start acting now.
Well, actually, we'll talk about read-only domain controllers. So if it's a read-only domain controller, it's not that big a deal. But yeah, it is. So what time is it? We're running about 35 minutes at this moment. Is there anyone still sitting comfortably? All right, I thought so. Yeah, so this is a problem. So first of all, 2 days ago, Microsoft released a script on the Technic Gallery, and it's reset-KRB TGT key interactive. And you can download that. That is also free, luckily, just like Mimikatz. And because and this is funny because the script, the download location, doesn't say it, but there's some really real good continuity features in the KRP DGT password stuff, because if you change it, that's okay. Tickets that are encrypted with the previous password are still valid, because we're not going to log off people just like that. So the script, and this is important, will change or reset the KRP DGT password once, and we'll make sure it replicates to all domain controllers. Now, once you do that, wait something like a week, because the default DGT its lifetime is a week. It's renewable for a week. And then run the script again. It doesn't say that on the default location, but at least there's a script. At least there's some guidance now.
So after you have run the script twice, that's the moment when this user that ever had your KRB TGT secret will no longer be able to create its own tickets.
That's kind of a solution for this problem. So let's look at the other stuff. BitLocker drive encryption. In Hyper-V, in Azure, yes, BitLocker drive encryption is supported in virtual machines on Hyper-V and on Azure, but it's not supported on the system and boot volumes. And if you do, the TPM key, because the virtual machine does not have a virtual TPM yet, the keys will still be stored inside the VM. In case of the Mimikatz demo that we did, the way an attacker would do that is through the integration components with system. The machine would already be running. BitLocker drive encryption is transparent to the machine when it is running. BitLocker drive encryption does not attack against that attack.
It's for offline attacks. So
Yeah.
if someone gets the image of your domain controller,
A
you will
VHD.
not be
Yep.
able to access the secrets. Because if you run Mimikatz, you are not required to do a interactive logon as I just did. You can just steal ntds.dit from that system and the system hive, and you're ready to go.
In most cases.
Yes.
Yep. So this is part of a solution. Mostly. Another part would be, if I have VHDs of domain controllers running, I'd better make sure that my backups are encrypted as well. If I have all that stuff, all those processes in place, to have the VHDs of my domain controllers secured, and they're just put on tapes or disks and taken out of the office, left inside a car, I don't know, stuff happens. No, encrypt the backups. Most hardware already does encryption, so the tape is tied to the tape device, and you can add on to that with encryption based on an account or a password or a shared secret. You could, but there's a catch-22 here, you could use Active Directory authentication on your backups. Really? But my Active Directory just was hacked. Why would it? Wait, okay. So that's... on Hyper-V, we'll just go through them. There's default access control list on VHD files and VHDX files. As you can see, an admin has full control over a VHD. That means an admin, but also someone in the Hyper-V administrators group, can just left-click a VHD, right-click it, say copy, go to, I don't know, some USB stick, paste, gotcha, let's go. Just like that. There is a Hyper-V administrators group, we'll get to that. And actually, the VM itself only has read and write access. The VM itself is the most locked out, well, not locked out, the most stringently protected. Yep. You can change them, but if you do, NTFS always allows administrators to take ownership. So if you say, well, administrators, goodbye. An administrator could always say, why did you lock me out? Here, I'll just take ownership. I'm back. Well, one of the things that you could do is use server core virtualization hosts in Hyper-V. So I tell my customers that server core is great because you can't have click and miss admins, certified click and miss admins, MCSEs, just doing wrong stuff. But also, in a server core installation, there's less attack surface for someone to actually run an exploit to get admin rights, and thus the system access to the VMs and stuff like that. You get better performance, all that stuff. So this is a good, I think this is a very good part of a solution if you want to run your domain controllers securely. Now on Windows Server 2008 and Windows Server 2008-02, you must choose the installation option at install. There's also a Hyper-V server installation option that is a server core installation with just a Hyper-V role and some other roles that don't really matter. And then on Windows Server 2012 and 2012-02, you could just install it as a fully blown Windows server with a graphical user interface, with the GUI. And then if you're done fiddling around with settings and stuff, just convert it to a server core installation by removing the shell. It's just 3 PowerShell commands. Anyone can do that. I should ask my 5-year-old at home to do that one, just to make that stick. Yep.
Okay, and then there is Hyper-V administrators. So you should be aware of the local administrators, and then there is a group called the Hyper-V administrators who are not the local administrators, but who are the administrators of your virtual machines on your Hyper-V host. Meaning that they can do anything with any VM on your Hyper-V host. You should trust your Hyper-V admins just as much as you trust the domain admins on your domain controllers. Because there is no way to keep your Hyper-V admins out of your VMs. Especially those integration features have some very interesting stuff in there to actually provide a backdoor, maybe you can call it, to your VMs, and do just anything with it.
Yeah, well, we've mentioned them a couple of times, those integration components. So yeah, they're on, they're there, they're running a system in VMs. You can selectively turn off some stuff. There's some stuff that isn't mentioned in the list, like the VM generation ID. You can't turn that off on a per VM base. And by default, there's a couple of options enabled. So it's the operating system shutdown, which is kind of useful. Time synchronization, which is essential for virtual domain controllers. So whatever you do, don't turn that one off. Then there's data exchange. Do we really want that? That would be a good candidate to disable. Heartbeat, we do want that. And backup for volume shadow copies. You could argue about that.
Read-only domain controllers.
Yep, read-only domain controllers. So this is a feature that was introduced in Windows Server 2008. You can have a domain controller that is read-only from an Active Directory point of view. So yes, there's admins local there. They can do stuff with drivers and that kind of stuff. And then there's role separation, so they can't do stuff in Active Directory themselves. So and it's read-only. And the good thing about read-only domain controllers is that a read-only domain controller has its own KRB TGT secret. It has a different KRB TGT secret than the rest of the domain. So this is a good security feature. If you have Hyper-V boxes in branch offices and you want to have domain controllers there, make sure it's read-only domain controllers. Now there's one problem with read-only domain controllers. Not every application supports them. Some applications still require a fully blown domain controller, so a read-write domain controller. So test, but make sure you have a preference. Oh yeah, yeah. I promised a Windows NT 3.51 tool in this session. Well, here it is, Sysky. Who knew of Sysky before he came to this session? Have you used it? All right, cool.
Nobody does.
Nobody does, and I don't know why. Because Sysky offers additional protection of the secrets in the local SAM, but also on the domain controller in the Active Directory DID. So what it does, it adds an additional layer of AES encryption on the hashes as they are stored in Active Directory. Let me just show you. Yes. So this is Sysky. It even has a good old Windows NT feel to it, doesn't it? And then there's a button, it's called Update. Let's try that. Update. And these are my startup options. So I can have a domain controller that every time when it boots, it asks for a password. Do we want that? That might not be that convenient. I can have it stored on the local device, so on the local hard disk. That might help, but if tools see everyone using Sysky, then they'll just say, well, you have to use the ntds.did and the system hive. Oh, and there's a little file for Sysky that you also want to use. So then that protection goes away. And then there's, and this is the interesting thing, I guess, because yeah, this is an NT tool, so it's all about floppy disks. We can have virtual floppy disks for Hyper-V machines, remember? You can have them in a different folder somewhere, hidden, so no admin can see it to take ownership. Give the virtual machines rights, that's it. You can do that. It's a bit of a hassle, but you can. If you do, however, because Sysky offers additional protection, you will no longer be able to use stuff like DirSync, Azure AD Connect, because it doesn't expect that extra protection. So this is strictly local protection.
Yeah, and it is something that was valid at the time. At the time, we had issues with not so good encrypted passwords. We had LM passwords, we had anti-LM passwords, and those were encrypted with RC4. And there were rainbow tables. And a rainbow table is just a very large table that says, here's a hash, and this is the password that goes with it. And if you had such a really large table, and you also had all the hashes of your secrets in your domain, you could extract most passwords from your domain controller. Now, what I just showed you with Mimikatz is not extraction of the password. I was not interested in the password.
Just the hash key.
Just the hash. And if the hash is encrypted with this Sysky, well, then there is an extra hurdle. But most of the time, if Sysky was used, you would ask Sysky to store the Sysky in memory or somewhere on the system. Now, what Microsoft did at that time, they used a 120-bit key that was hidden in 128 secret places in memory. I cannot imagine that those 128 secret places are still secret in 2015.
Oh yeah, or that Sysky does stuff like ASLR and DAP and stuff like that. Can't imagine that as well.
Okay.
It hasn't changed. So what we're really up against, if we want to run virtual domain controllers securely on Hyper-V and Azure, is that we as admins have to get help from other people. As as Active Directory admins, we need help from Hyper-V admins. Thank you. We need help from branch office admins, branch office people. We need help from the people that handle our backups, that transport our backups, that store our backups. We probably need the help of our marketing department for communication. No, this is not a security hurdle. No, we're not here to punish you for using the system. This is about security. This is why we do stuff the way we do it. And of course, and this is the stuff that we really, really hate, we need to document the things that we do, the things that we change. Right. I almost forgot about this slide. How much time do we have?
10 minutes.
10 minutes. Oh, cool. All right. So I promised you an NT 3.512. I've showed you that. Now I'm going to show you something that is in Windows 10, the technical preview. This is in the latest build. So the one that is out for a month. I'm running it on this system. That is why Siski looked rather decently. And I'm going to show you just quickly. So this machine does not fulfill the requirements for that, but what we have in terms of BitLocker drive encryption is currently an inability to supportedly BitLocker the system and boot drives of our virtual domain controllers. But yesterday I was shown this tool. Oh, I'm sorry. That was not supposed to happen. Control 1. That's it. It's a WMI Explorer. It's a free tool. Okay? And I'm just going to connect to this host that is running Hyper-V. So in the WMI, I'm going to Virtualization v2. Just like that. It is here because it's running Hyper-V. And it will show me all those classes. It's 314 classes. So yes, Hyper-V is advanced. I'm going to search for TPM, see what happens. And here I have something that is labeled the MSVM underscore TPM. If you Bing this, nothing shows up. Sure. If you Google this, nothing shows up.
Reality check.
Yeah, reality check. But if I look into this with WMI Explorer, let me just get that one, and get the virtual machine that I just shown you, I get some interesting stuff. So apparently, in WMI, in Windows 10, and in Windows Server 2016, coming up, is a Microsoft Virtual TPM. So now, what I can do, and heading back to the slides for that, because something has been said, on the roadmap for Azure, this very feature is called client-side encryption for Azure storage blobs. And it's in development currently. Well, as we've seen in Windows Server 2016 and in Windows 10, it is also in development. And if this is true, and this is something that I really, really like telling people, there's new Hyper-V stuff coming. Hyper-V, the enterprise virtualization solution, in Windows 10 first. How cool is that? So, well, may not be as cool as you, well, yeah, it may be cool, but you can even make that really super cool, because there's also something like the Azure Key Vault. And this is a cloud-based HSM, hardware security module for keys. You could actually, probably, and this is really cool, if you don't trust anyone within your organization, but you trust Azure, yeah, that just might be the case. You can store some of the keys in that scenario in Azure for you.
Would that mean that you can run actually BitLocker on a computer's
So the question
environment?
is, does this mean that in the next version or in Azure soon we can run BitLocker on system and boot volumes in virtual domain controller? And the answer is yes.
Probably yes.
Yes. Yep. Now, to get back to the essence of this session, does that solve, if we're able to run BitLocker drive encryption on all our virtual domain controllers, does that solve all of our challenges? No.
No, it solves the challenge that someone can steal the VHD from your Azure tenant, and that person will not be able to access the contents of the VHD because it's encrypted. But if you're the administrator of the Azure tenant, or the administrator of the Hyper-V host, then you still can do anything with any VM. I learned yesterday evening that there is a lot on Azure that I hadn't found out yet. If you have VMs running on Hyper-V, or on Azure, I should say on Azure, there are ways to access your VM to, for instance, reset your password of your local administrator. You can do it yourself if you are the tenant.
Yeah, through PowerShell. Yeah.
Through PowerShell. There are ways to run just any script you want on any VM in your tenant. So you don't have to be the local admin on those VMs on your tenant to be able to access them and do just what you want with them.
So you can actually run Mimikatz through a script and get the data back?
Yes.
Yeah, you could actually run Mimikatz through PowerShell extensions on a VM in Azure. Yep.
With system runs?
Yep.
Yes.
Yep. And all you need is the Azure tenant account credentials.
And BitLocker won't help you because you're in an online situation, not an offline situation.
Exactly. BitLocker
BitLocker
will
won't
not
help.
protect you from that.
All right. So the main conclusion is that running highly sensitive domain controller, and every domain controller is highly sensitive in my book, on Hyper-V and Azure is not just a technical challenge. Anyone can virtualize a domain controller. Virtualizing it securely, safely, that is a challenge. If you feel that that is a big challenge, or that you don't have the tools today or tomorrow to face that, I think you could ask yourself the question, do you really want to virtualize your domain controllers?
That wraps up our session.
Yep, that wraps it up.
Thank you very much for being here with us this morning. If there are any questions, we're still here today. We're doing another session this afternoon at 1:20.
And we're going to show you another unannounced, undocumented feature at 1:20.
It's been announced, but it's undocumented.
Has it been announced?
Yes.
Oh, okay. Well, I couldn't find anything with Bing. Oh, wait. Okay. Just to be sure, this session, the audio is recorded. So if you have any questions that you feel that people watching the session could benefit from, please ask us the questions now. We'll repeat them for the audio, and so that everyone can hear the answer in the recording. Any questions? That many?
The Mimikatz demonstration.
Yes.
How did the attacker get hold of the hash? Was it because a domain admin had logged on locally on the workstation?
Yes.
Repeat the question, please.
The question was, how did I get a log on that domain controller? Well, usually it starts at just an ordinary workstation. And what those hackers do is that they start with a simple target. It may be an ordinary user. And if you are able to be the local admin on any system, and I think everyone here has colleagues who are local admin on their workstation in the enterprise network, then you just make a call to the help desk to let them fix something on your system. As soon as the help desk support engineer accesses your local system and you have Mimikatz available, or you create a dump of the LSASS executable file, executable process, then you have access to the secrets of the support engineer. So now you have access to all the systems, probably all the workstations in your network. Then the trick is to find this single workstation where the domain admin logged on. If you found that system, then you have the credentials of the domain admin. If you have the credentials of domain admin, you are able to log on to a domain controller. And if you are logged on a domain controller, being a domain admin, you have access to the KRB TGT secret. And then the network is yours.
For 10 years.
But that's the way things happen. Huh? It always starts with a simple target, easy access.
Yep, it is 10 o'clock. We would like to thank everyone for being here, for showing up early. Thank you.
Thank you. And yes, if you like the session, please leave us an evaluation.
Yes, please leave us a green evaluation if you liked it.
Well, if you didn't like it, thank you very much for joining us.